In this video, we're going to look at fractional indices at National 5 level. This is certainly when we're now progressing towards the A content in National 5, and it has huge links that are higher. These come up every year, more or less in every lesson as well, so it's important we can understand them. I want us to think back to surds for a moment. If we recall the problem root 5 times root 5, that would become the square root of 25, which is 5. Remember we had that shortcut. Root 12 multiplied by root 12 is simply 12. So we can generalise this to root A times root A is equal to A. This is a general form of this problem. Hopefully that's okay so far. But let's think a wee bit closer. What I'm going to do here is see this A, that's the same as A to the power of 1. And hopefully you can see that I'm multiplying two quantities here, and generally when I multiply two things, the powers would be the same. But do you see how both of these quantities are exactly the same? So it holds true that the square root is the same as a half. Because if I look at this problem here, if I were to multiply these, I would add the powers, so I'd do a half plus a half, which is 1. So what we can generalise from here is we can say that the square root of A is the exact same as A to the power of 1/2. Similarly, we can say that the cubed root of A is the same as A to the power of 1/3. The fourth root of A is the same as A to the power of 1/4. Because technically when we're looking at square roots, there's some hidden numbers here. Technically, we've got that value there when we're thinking about the square root. And technically, if you like, these are all to the power 1. Hopefully you're going to be able to start seeing a pattern here. So like so. So if we've got the cubed root of A, that's the same as A to the third. The fourth root of A, that's the same as A to the power of 4. So you can see how all these values are starting to tie together. Essentially, what we can generalise this full idea to is the following. If we have got A to the power of a fraction, so if we've got something to the power of a fraction, that will become the nth root of A to the power m. So if we have a look at this example here, A to the power of a quarter. A to the power of a quarter, well that's going to be the fourth root of A to the power 1. And we don't usually write to that power 1, but that's how these ideas are equivalent. But let's say we had a different power. Let's say we had x to the power 2/5. Well, this would become the fifth root of x squared. Similarly, if we've got y to the power 2/3, that's going to become the cubed root of y squared. And why is this helpful? Well, it's helpful because it allows us to work out some probably quite challenging number problems. For example, if we wanted to consider this problem here, if we wanted to evaluate 32 to the power 2/5, you don't know that off the top of your head, but what we can do is we can reimagine this problem as the fifth root of 32 squared. Because the fifth root of 32, what times itself 5 times is 32? Well, 2, because 2 times 2 times 2 times 2 times 2 is 32. And then we're left with 2 squared, which is 4. Similarly, if we wanted to evaluate 125 to the power of a third, and the power of the third is the exact same as the cubed root of 125. And if you want, that's to the power of 1. So what times by itself 3 times is 125? Well, it's 5 times 5 times 5, it's 5. That's 5 to the power of 1, which will give us 5. Okay, so big idea here, when we're working with fractional indices, if we have a quantity raised to a fractional power, we can write that as the nth root of x to the power m. Similarly, if we see something like this here, let's go for that. We'll do the square root of, let's say, w to the power 9. You need to be able to translate that to w to the power 9 over 2. Okay, thank you very much.